Hello, welcome to this new video. My name is Alessandro Saltarin, my classmate Mauricio Dionato Sanchez, and we're gonna present you circular double linked list research papers. The first document is a new improvised circular skip list with priority search. The description is, in this paper, a new data structure named Improved Circular Skip List, or ICSL, was present. This new data structure is the combination of two data structures, is circular linked list and skip list. Research problem. Time complexity of search, insertion, and deletion of circular linked list and skip list could be better with this new data structure. With this data structure using a priority search that was performed by using frequency. Using frequency is a number hit search, and which improved the efficiency. Proposed software solution. The innovative search algorithm of this data structure was called priority search, used in ICSL data structure. It benefits from the pyramidal structure of the skip list. And this new algorithm is better for the time complexity. And the purpose of this is, if a data has greater hit search number, then it was upgraded in the skip list data structure to upper level. In other words, if you search a number, for example 4, but you search this number 1, 2, 3, 4 times, so this number is gonna to upper level in the pyramidal. If you don't search frequently this number is stay in the same position or in a lower position. The time complexity of searching in the skip list, the normal searching, is O log n, but with priority search is approximate to O1, and the time complexity of searching by using priority search algorithm change between O1 or O log n. And also, when you search a data, is upgrade. Every time that you search a data is upgrade, is upper level or lower level. It's each search process. The conclusion of this is that this new data is created for the time, because if you could upgrade the time, it's better with the time. Okay, so the improvised priority searching was better than the standard of searching in skip list and the circular list. And this is the solution of this problem. In my point of view, is great that use a very good technique to save time and searching of data. Because if a data is searched a lot of time, it's good that the option is in the first. Yeah, it's better for you because its speed is quickly and the time is short. And also this data structure is good with the data is so big. Is better use this data structure.
Now I'll be talking about building an Uno card game and a Netflix representation using circular doubly linked lists. This paper primarily focuses on the uses of circular doubly linked lists and how its implementation can benefit certain processes by making them faster. The purpose of this paper is to describe how to represent two real life scenarios in code by implementing doubly circular linked lists and how these processes in these scenarios could benefit from using the structure. The proposed software solutions. For the Uno game, the proposed solution uses an object-oriented approach centered around abstract card objects and concrete player objects, where each card is either a number card or a condition card, for example. When the program begins, a method is used to deal all the cards to the players. The players are stored in a circular doubly linked list, and each of the nodes represents the players. With the use of a method that is composed of 2 cycles, 7 cards are dealt to every player. After each of the players has cards, enough cards, a deck, after each player has a deck of cards, a method to shuffle the cards takes place. In order for the players to be able to play the game, a separate method was written that would determine if the card being played matched the card on the discard pile. Now, for the Netflix scenario, a system based on movie objects was designed. After each movie is created as an object, it is added to a master list. This master list basically is a circular doubly linked list that has many lists in it. Like, okay, we have the master list, and inside that list, there are categories of movies. Well, when the movie is created, it is added to the master list and is also passed as an argument to a method that will place it into the appropriate category. For this scenario, a GUI was also created using JavaFX. Now, this proposed software solution uses a Netflix class, which implements a method that compares two or more categories and returns a new list. From my point of view, circular doubly linked lists are superior when it comes to regular linked lists, just like the conclusion drawn in class. However, it seems to me that this paper focused too much on proving a point that was already proven. And even though it was interesting to read about the ways the authors came up with the methods and the GUIs, it still felt to me like this paper was kind of redundant. Now, lastly, we'll be talking about smart game development on removal of every K player and find the winner using linked list concepts. The main objective of the proposed research work is to create a smart game service using linked list concepts. The problem statement of the smart game service is the removal of every K or key player and to find the winner of the game. The proposed work creates two different approaches for the given problem. Approach 1, considering the scenario to get the time taken by each player in each round and eliminate the player who takes more time. Finally, the player with the less time gets announced as the winner and he is displayed with his assigned number in the screen. Approach 2. The statement states to eliminate the key player with respect to the random position. Taking in consideration the random position from the user in each round. Finally, the player remaining is announced as a winner. Okay, for the approach number 1, the structure goes like this. Step number 1, start. Step number 2, declare the structure for the player ID. Step number 3, declare the structure for the lap time. Step number 4, check if the number of players is positive. Step number 5, open the file named playerids.txt. Step number 6, check if all the player IDs are unique. Step number 7, run a while loop until the number of players becomes 1. Step 8, declare the remaining player's player ID. Step 9, print the winning player's ID as an output. And step 10, stop. Now, for the approach number 2, the structure will go something like this. Step 1, start. Step 2, declare the structure of the player ID, player list. Step 6, accept the number of players as an input. Step 7, calculate the number of rounds to be played and disp. Step 10, accept the elimination position as an input. Step 11, run a while loop until the number of players becomes 1. Step 12, declare the remaining player's ID as a winner. And step 13, print the winning player's ID as an output.
In the first case, in approach 1, number of players is 4, player ID 37911, each has memory address. So the fifth round, the time. The longer time is 170. So we're going to remove this player. The player is 9. The before player, in this case 7, will be connected with 11, the other player. And 9 is removed. After removing player 9, the player is 3, 7, and 11. In the next round, other time, the longer time is 140, and delete this player, the player 11. The connection is delayed, and the only player is 3 and 7. And the other round, the longer time is 100, so the only player, the winner, is 7. And it's a simple solution. You just need to delay the player with longer time. In the case 2, the number of player is 5, the elimination position is 2, and number of round is the number of player less 1. In this case, is 4. So we're going to eliminate player in position 2. In this case, 1, 2. The player 576. The connection is the first player with the next of the player eliminate the player that we're going to eliminate. And this is the case. And the important of delete the player is that we need to stay in the position. In this case, we're going to put in this position, and the next round, we're gonna delay 1, 2, this player, the player 450. And in this picture, we see the situation, and we correct the connection. And the other player that we will be eliminated is 1, 2, this player, the player 260. In this picture, we see the situation, and we connect correctly. And in this situation, the other player that we're gonna be eliminated is this player. And the only player, the winner, is 385. And that's important that this data structure is that you need to save the position and continue eliminate the other players. The conclusion is that in the case one is a simple solution. You don't need to move element or insert element. So the solution is less expensive in terms of memory. And in the case two, to solve this problem, we need to using a circular linked list is useful in this case. Any node can be a starting point. We can traverse the whole list by starting from any point. Is so good this, and we just need to stop when the first visit node is visited again. It's a circular linked list, so the only way to stop is that found himself. Okay, the first node that visit. And it's useful in application to repeatedly go around the list. In my point of view, this document is so important because you know the importance to use a correctly data structure depend of the problem. Yeah, in case one, since only one player has to be eliminated for one round, so there's no need to use a circular because depend of the time, and the time is changed for rounds. So it's a linked list, single linked list. On the other hand, in the case two, we need to say the position. And so when a player was eliminated, it's necessary to say the position, continue eliminate from there. So circular linked list is useful in this case. And also, we when we were in the last player, we can go to the first player normal because it's a circular linked list, so it's useful in this case. So it's the important to use a correctly data structure, but depending of the problem and the time and other things that we need to consider. And thank you so much for staying in my presentation with my classmate Mauricio Dionat.